we're asked to write the augmented matrices that go with each of these system of equations. Okay, so for the first one, I have two variables and two equations. So a matrix, I've got these square brackets. Notice that my equations are arranged in the same order, x's, y's, and on the other side the number. That's the order that I need them to be in to write this augmented matrix. And I'm just going to pick off the coefficients or the constants that come from this. So in the first row, I'm going to look at my first equation. There is 1x, 4y's, and the other side of the equation is 9. And now do the same thing with the second equation, 6x's, negative 7y's, and 18 on the other side of the equation. And then to kind of put in a placeholder for the equal, what we often do is put a bar through here. Sometimes it's dashed or just straight, but that just kind of separates, here's the equations of the variables, and here's what they equal. Now in this one it's very similar, but I have three equations and I do have three variables, so this matrix is going to be a little bit bigger. And I also put a little twist in this one. If you compare the first equation with the second equation, the first one had x's and then y's, and here I reversed it. So you do have to watch for that. So just to the side, I'm going to rearrange this to be in the same order with the x's first. Don't forget the sign in front, so it's negative 2x's plus 5y's minus a z equals the number 7. And there's a little bit of twist on this last one as well. Notice there are no x's here. So if you want, you can even just put in here 0 x's, because we can't just ignore it. We still have to put in the coefficient in our matrix. So now if we follow through, x's on my first row, I've got 3, negative 2y's, 8z's, all equal 4. Second equation, the x's, I've got negative 2, 5y's, negative 1z, 7 on the other side. And then the last equation, 0 x's, 1y, 6z's, 0, and then I'm going to put my divider here. That is our augmented matrix for that system of equations.